Hi, welcome to my machine learning framework named FLUX. So, a machine learning framework is a software or algorithm that helps us develop, train, and deploy machine learning models in the real world. We know of many open source software such as PyTorch and TensorFlow. These are all machine learning frameworks, and Flux, which is this framework, is the framework I have developed to also train neural networks and effectively model real-world data. So the test we are performing is called the 4-bit parity test. This is a very standard test that is used to check for data corruption in the real world. And the first four columns are the inputs and the last column is the output. Here I'm using a matrix mathematical library that I have developed specially for this framework. If we go to the definition, so you can see I have a matrix class here, and this performs the calculations. It has the matrix add, subtract, all of the mathematical calculations that is needed in a neural network. But since this video will be too long, I will keep it short and simple. I do have a very comprehensive documentation on my GitHub on how this is working, how my framework is working. But here I'm separating it. It has 16 sample size because there are 16 inputs, and then you have 4 parameters here, and this has been divided into an input and output matrix. So the form network is responsible for forming the skeleton of the network, which I'll quickly go through here. So this is the form network function. Form network function, it will form the skeleton of the network, and it has 4 implicit input neurons and 2 hidden layers that consists of 8 neurons and 4 neurons and 1 output layer. So it is a 4-8-4-1 network structure with the dense layers. These are all dense layers, and this is the input matrix and this is the output matrix that is being fed into this function, and the activation type is the leaky ReLU for the hidden layer, and the sigmoid activation function is used as the output layer. My goal is now to model this non-linear output here. I will now run the program to check and see if my program can successfully model this non-linear output. And this is the function that is responsible for creating a graph at the end, which we will see later on. And this is the learn function that helps correct the mean squared error, that is reduce the mean squared error. So now we will run the program and see how this model is working. So as you can see here, I have printed out the neural network structure here. This is the model structure. It has 4 neurons, 4 input neurons due to the 4 parameters here, and 2 hidden layers. One of the hidden layers has 8 neurons and another hidden layer has 4 neurons, and the output layer is 1 neuron. And for both of these hidden layers, as I have described previously, we use the leaky ReLU activation function, and for this output layer I am using the sigmoid. As you can see, this is the initial mean squared error. So the mean squared error is decreasing every time. For every iteration it is decreasing, and I'm printing this out. As you can see, it started with 0.23 and now it is 0.212998, so it is very close to the original result. So for now, if the mean squared error is decreasing, there is a very high chance that this model is learning and it can show the output that is shown here. So we are just now waiting for the number of iterations to end, and as you can see, a graph has been printed here, which I'll describe later. But first, let's check if our model has successfully trained. Our model has been successfully trained or not. So we are matching the output here: 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1. 1 0 0 1 1 0 0 1 0 1 1 0 0 1 1 0. So as you can see, our model has learned this structure, this input properly. This modeling is correct, and then we can see the graph of the mean squared error versus the number of iterations. So this is 0.24 and it is decreasing. As you can see, it was learning quickly and then it stalled because it is very close to the zero. And this is how my neural network framework, my machine learning framework can model these inputs. Thank you.